Hello everyone, welcome back to the class of Math 1450, Math and the Modern World. And this is the continued discussion on permutation, especially factorials. Last time we introduced the operation of factorials. N factorial, it is a product starting from the number n all the way down to 1, like 4 factorial, 8 factorial, 9 factorial, all those things, okay. And also one important thing is worth to mention, because factorial operation, it is considered as a product, and 1 factorial, certainly no doubt, it is 1. And also, somewhat interesting enough, we do have 0 factorial. You may want to say 0 factorial should be 0, right? But it's not just true, okay? Make sure you know 0 factorial, it is 1, okay? 1 factorial, it is 1, as you may expect. 0 factorial, it is 1, 2. 0 factorial, it is 1, 2. That's for the moment, just remember 0 factorial, it is 1, 2, okay. It is 1, okay. So we move on to the discussion of permutation. And permutation, basically, it is the way we want to count the number of outcomes, And well, factorial, it does count the number of outcomes, count 10 out of 10. And then the question is, what would happen if we want to count the number of outcomes, count 3 out of 10, or maybe 5 out of 10? So if that is the case, in a more generalized way, we say we are going to take out all objects out of n. So the total different outcomes, the total different results, it is denoted using the notation NPR. It reads the number of permutations of n objects taking all at a time. NPR, okay, NPR. And then using the multiplication principle, I hope you remember, I should have put this formula first, okay. Remember the example we did earlier, 8 swimmers, and we want to find out a number of different ways. So we have arranged podiums for the first 3 places, first place, second place, third place, the situation. Then 3 out of 8. It starts from 8, then 7, then 6. Right, it does not end at 1. If we count 8 out of 10, 8 out of 8, it starts from 8 all the way down to 1. But we count 3 out of 8, so it starts from 8 all the way down to 7, down to 6. And similarly, NPR, it starts from n minus 1, and all the way down to, if you count very carefully, the very last number taking r out of 10 would be n minus r minus 1. And also, if somewhat you get confused with the notations n and r, and somewhat we have a little bit of better arrangement, but it does involve with quotient. But you want to know the quotient simply simplifies into a product. Okay, it's never quotient. When we count a permutation, it cannot be a fraction. It's just an integer. Okay, so it is n factorial over n minus 1 factorial. This might be, yeah, I think it is better to remember the permutation formula in this fashion. But do keep in mind, it is just a product. Okay, it is just a product. And also now, maybe we can take the opportunity to take a look. Remember, we didn't mention 0 factorial. 0 factorial, it is 1. And this time, hopefully, we can give a little bit of reason to tell why 0 factorial has to be 1. Okay, because when we consider the permutation, like a 10 out of 10, 8 out of 10, or n out of n, NPN. And using the formula, it says that it will have to be n factorial on the top, right? And the denominator part, it's n minus n factorial. So in this case, you see, we are having a 0 factorial in the denominator. And we understand in any kind of math, okay, 0 cannot be the denominator. 0 simply denominator cannot be 0. So we do need to make the 0 factorial as 1 here. 0 factorial as 1, okay. So this is the permutation formula. Permutation formula. You can remember. I think you really need to remember in both ways. It is a product, and then this product somewhat can be shortened in the fashion of a quotient. In a fashion of a quotient, there are two factorials involved. Okay, n factorial, bigger factorial on the top, then denominator it is n minus all factorial. This quotient formula, it's I don't want to say it's a little better because it might be helpful because our next topic it is combination, and when you count a combination, you do need to use the formula of the quotient like this. It's a lot easier to use a quotient like this. Okay, but anyway, for the moment, it is about permutations. So let's take a quick look some examples on the calculation of permutations. The number of permutations of 12 objects taken 3 at a time. So in notation, it is denoted by 12p3. In the actual calculation, it is 12 factorial over 12 minus 3 factorial. Doesn't make sense. I'm going to pause a little bit. You take a look if it really makes sense. This is what I'm talking about. Okay, you are taking 3 out of 10. So the number of permutation, it is written as 12p3. And then if you remember the formula, this is how the formula would look like. Don't forget the denominator, it is also factorial. Okay. And then I really want to say here is in this case, practically I would say it's a lot easier instead of considering 2 factorials, because in the end, this is how it really works using the multiplication principle. We are considering the arrangement of 3 out of 12. So the first choice, there are 12 possibilities. Second one, 11. Third one, 10. We multiply all of them together. Okay, but anyway, the formula still works very well. Okay, and similarly, we are taking out 5 out of 8. So it's denoted as 8p5, and we do the calculation, and we get the number. The last one, I still want to say, you remember the permutation, it has to be a product, okay? So literally, we are taking 2 out of 32. It has to be a product of 2 numbers, 2 out of 32. First place, we have 32 different choices. Second place, we have 31 different choices, so 32 times 31. And also, if you rely on the formula, I say in this case, the formula does look a little more complicated, right? But it is the same, okay? It is the same. That's all about the permutation. And also, there are a little more exercise for permutation. I guess if I read all the problem right now, you may not follow clearly. And so I'm going to save the remaining part for you to read to see everything, if everything makes sense. And if you have questions, let me know. And again, thank you for watching.